Here is a question, which is a practice problem for linear relations. Question is, an airplane flying at an altitude of 1500 meters begins to descend, that means coming down, at 40 meters per second. Is this a direct or partial variation? Explain. Write the time position equation. And part C is, determine the time when the airplane will land if it continue to descend at this rate. So once you have answered the question, you can listen into my suggestions. Now the very first question is this a direct or partial variation? Direct variation is the one where the starting point is always origin, or the graph goes through origin, right? So that means at the instance when time is 0, then the altitude should have been 0. In our case, we have an airplane flying at an altitude of 1500 meters begins to descend at 40 meters per second. So if we take t as independent variable and altitude, say another variable, a as altitude, in that case altitude is 1500 when t was 0, and therefore it is not a direct relation, but it is a partial variation, right? So we'll call it a partial variation. So origin 0, 0 is not a part of this solution. Write the time position equation. Now for writing time position variation, we need to define our variables. So independent variable is time for us. Let's say t will represent time in seconds since the plane starts to descend, right? Or just after it starts to descend. So that is the independent variable, and as the plane starts descending, what happens is altitude or height decreases. So we can have the variable h as height or altitude of the plane, right? Which will be in meters, correct? So these are our variables, and based on these variables we can write down the equation now. So we can write down equation as height is equals to the rate at which it is descending is 40 meters per second. Since it is coming down, this should be negative. Remember that. So 40, right? And the independent variable is time. So we get time plus from where? From the height of or the altitude of 1500 meters. So that gives us height in terms of time, right? And this is the time position equation. Remember, when we are talking about position, we see distance, height, depth, all these are positions. Determine the time when the plane will land if it continue to descend at this rate. So at the time when plane lands, what is going to be the height? 0, right? So to find that answer, you need to plug in 0 for height and then find what time is. So we can rearrange the equation and get the answer. So we get 40t equals to 1500 and t equals to 1500 over 40. And using the calculator, you can always find this answer, right? So we get 4 will go 3 times, 12, 30, 7 times, and then 20.5. And the units are seconds. So after 37.5 seconds, plane will land, right? If it continues to descend at the same rate, steady rate of 40 meters per second, correct? Now as an added exercise, what you can do is, you can represent this information in a graph. So plot a graph and explain why your graph is a continuous line or it will be a scatter plot. Thank you.